Sorry, the video got cut off there. So what I was saying was that sine is made up of the opposite and the hypotenuse, and if I want to know just the opposite by itself, which is this component or this component down here, they're the same thing in terms of vectors, then it is just rearranging the sine version of things, which is opposite over hypotenuse. Then the opposite is just the hypotenuse times sine of theta, which is this here. Okay, so right, if I know that I'm going to call it B parallel, which is the one that's parallel, it is the hypotenuse times the cos of my angle. So the hypotenuse has a size of 3, and I'm doing that times cos of 60 degrees. Okay, so 3 times the cos of 60 is 1.5. Okay, so it's half up along, half as high as it is across. And then B perpendicular is 3 times the sine of 60 degrees. All right. Sine of 60, and that is 2.598. Okay, so it's almost as long out this way as it, like 2.6 essentially compared to 1.5. So it's very, very strong. So that's Tesla's in both cases. All right. So we were asked to do that, and which component causes the force on the wire? B perpendicular causes the force because of our Fleming's left-hand rule. Okay, that the perpendicular component to the current causes the force on it. And then it says, what is the magnitude of the force and in what direction does it act? So look at this. It's going to act, into the page. There's my I, my current, be perpendicular, and then it's going to act into the page, but let's find out the size of it. So F is the size of the magnetic force, be perpendicular, times I times L. Now, normally we would say do B times the sine of theta, but I've already done that here. So I'm just going to use 2.598 because that is B times the sine, all right? Times I, the current, 2.5, times L, half a meter, times 2.5 times 0.5. Now actually I still had the full version of this in my calculator, so that's what I'm working with here. And that gives me a force of 3.25, let's round it up, newtons into the page. Okay, because it's a vector, I've got to give the direction as well. So what I'm using here is my left-hand rule, but my current is, in the way I've drawn it, the current is going up, and then the perpendicular component is going that way, so it is into the page. What I could, just to be absolutely clear, perpendicular to both current and magnetic field. Okay, hopefully that is enough.